Hi, I'm currently doing Paul McWhorter's Pico W lessons, and because I've got such a bad memory, I thought I would start to make a video on a certain subject and put everything that I know about that subject in the video. I've already done one on print, so this one's on decorators. Now, decorators I didn't know anything about when I first used them, and I just thought, oh well, don't need to understand, I just put them in. But since then I've actually learned how to write your own and everything. So we'll just take a look at this. This is an RGB LED class that I wrote. It's in MicroPython, but it doesn't matter. The concept is the same, and it's got various properties as you would expect, like color and whatever. Now if you look at red here, that's just a method to return the first element of the RGB tuple, and if you put at property in it, it makes it into a property, so you don't have to worry about the self.color everything. You just, if you type in the class name .red, there you will have the value of red. And straight after that, if you have a at red dot setter, that sounds like a dog, then that red has to be the same as that red, and you could just go dot setter, and it means you can control how people, they can't just mess with your variables in your class. It has to go through there, so you can stop people doing stupid things. Now, I didn't understand anything about it. I just put it in and it worked. I thought, one day I will learn. So the easiest way to do this is to show you what I mean. Right, so I will import that. Then I will create a new instance of it using pins 1, 2 and 3, and then I haven't done anything to it. I set it up to be off, so red ought to be 0. Yep, red is 0, and if you actually look at what that is, it isn't a method anymore, it's an integer, because that's what red is, an integer. And so as well as that, you can go my LGB equals 255. Oh, and the light on my board has come on, but we aren't actually playing with that. And then you can see it, and it has worked. And then you can say, well, if red is 255, what is the color? So you can go, what is the color? You don't spell color like that. Americans miss out the U. I missed out the O. There, and you've got your tuple, which is 255 0 0, and you can change the color if you wish. You could go equals 0, 0, 255. Yeah, and it's now blue. Great. And that is just a much less clunky way of being able to do it, and it's all done with decorators. Now if you go my RGB dot pins, now I set it up to be pins 1, 2 and 3. 1, 2 and 3, yep. And up here somewhere, where are pins? Right, I've got the property there which is what is giving me back the 1, 2, 3. But if you notice, I don't have a setter for it, because it'd be pretty stupid to be able to set the pins of a class, because you don't want to, if you get my meaning. So if you go RGB pins equals 4, 5, 6, for example, it doesn't like that, and that's exactly what you want it to happen. What you want to happen, that you can't mess with things you shouldn't mess with. So once you get used to it, this app property and the dot setter, marvelous, marvelous, marvelous. Now the other things that if you're doing Paul's classes, you might recognize something like that. Now that is a decorator. Don't know who wrote it. Someone a lot cleverer than I wrote that, but that is another example of a decorator. So you could just use a decorator as long as you know, you read the documentation, and you don't have to understand anything. But I wanted to be able to write my own decorators. I don't know what's happening there. What if I press escape? Will that get out of it? No, it won't. Get rid of that. I don't really want to do that. So I thought it would be great if you could work out how to write your own decorator. Recently I've noticed that Keith likes timing things, so he'll have a function to do whatever, and he'll say, when did I start, when did I stop, therefore that's how long that function takes. But you can do it with putting under decorator, and you can debug, and you can slow down your code because you might want to. And I'll be leaving a listing of all my decorators in the description of this video in case people don't want to watch the video. But the rest of this video is going to be about how to write your own decorators. So you might be interested or you might not. Right, I've got rid of the RGB LED stuff. So in order to understand decorators, you need to understand functions. So take this function. That is just square, a function called square that returns the square of the number. So if you just go square, it will say, right, that is a function called square and it's at memory location that. And you can go square 3, for example, 9. Great. Then you can copy it, or you think you're copying it. Square 2 equals square. Now what has that done? So what is square 2? If you just print square 2, that says it's a function square at that same memory location. So what you've done, you haven't created a new function, you've just created a reference to the function square. Bit confusing. You think, okay, so what if I go square 2 of 4? Yep, it acts in exactly the same way. But as it's just you've got your actual function there at that location, and then you've got a reference to it at square 2 and square, you can delete square, and all that's done is deleted the reference to square, because you can still go square 2 is pointing you to the function square at that same location. So what you have to do is you need to get sorted out in your head that when the actual square is just a reference to the function square, which is a bit confusing. Take another function. Say hello name, right? If you just go say hello. That just says that it's the function say hello at that memory location. Then you can go say hello Peter, and it says hello Peter. You can have another function like that, and equally you can go how do you do, whoops, I need another there. How's it going, Keith? So that's all very basic. You can put in an argument to your function. Now, a function is just an object, so you can try adding them to a list, for example. And then if you print the list, yep, there you go, you've got your two functions, say hello and function how do you do. You can access this. So you're just accessing the first element in that list, and it says, yeah, it's a function, say hello, and you can put in argument, and it is just running that, executing that, calling that function, how do you do, with Mr. Burger in it. That's all very simple, how you would expect a function to work. But as a function is an object, you can pass it into another function. So if you, whoops, forgot to copy that, hold on, copy, you've got another function. Now what that does is, this function greet Paul, you put in a function there and it returns a greeting of Paul. So imagine that we put, we'll just print greet Paul. That is a function, greet Paul. But look at what happens here. You're calling that function greet Paul, and you're passing in say hello, which is a function. So say hello is expecting, oh, say hello's up there. Say hello is expecting an argument. So what it's doing is it's calling say hello, and it's taking Paul there. So sorry, I'm explaining badly. So it's going to greet Paul. Greet Paul says, right, I've got a function coming in there. The function is say hello. So then it's returning say hello Paul, which is what it ought to do. And it goes hello Paul. And you can do the same thing with the same function, the greet Paul function, and it's passing in how do you do this time, and it goes how is it going Paul. So that is just a bit of background on functions. Right, you can have functions within functions. So if we look at this, you've got this function outer which prints something, and within that it's got an inner function, and what I'm doing is it prints that, it calls the inner function that prints that, and then it says I'm still in the outer function. So if we go outer like that, it just says hello, I'm the function outer. But if you go outer and you call it, it does exactly what you'd expect it to. I'm in the outer function, calls that, I'm in the inner function, I'm still in the outer function. But even though you've got your function inner, you cannot do that. Does not like it, because that inner function is only existing within the outer function. So if we have a look at this other function, and this time you're passing an argument to it. So you can go outer 2, yep, that says I'm a function. Then passing the argument, you can pass in a 1, and it says outer function 1, so it's saying, right, I'm 1, so that's that, but you haven't called it, so you're just saying hello, that's the function inner there. But if you then call it, it does it, which is great. And you can do the same thing again if you go passing a 2 in as an argument. There, I'm in second inner function. You can assign that outer 2, 1 to a variable. So you can go first equals outer 2, 1, and that ought to return the reference or the location of, when you print it, it will return the location. Yep. So you can first is now pointing to that, which means you don't have to kind of climb in and do anything with it. And you can go first, what you call it, yep, and you can do exactly the same. You can go second equals outer 2. I wish I'd not used 2's and 1's all the time, it's rather confusing. Second is that. You can print second, yep, that's pointing to the second inner function, and you can go second like that. Now that is just a bit of a refresher of having functions within functions. Why did I do that? I wanted to. Now I've defined another function which is like that, and what this function is just called simple decorator. It could be called anything, and you're passing in an argument of a function, and then you've got this inner function which by convention is called wrapper, or it could be called wrapper something or something wrapper. Some people call it inner, and it prints I'm about to call the function, it calls the function, and then it prints I've just called the function, and then down here it returns that function, so it does the business. So what we need is another function to pass into it like that. Now if I go say hurrah, it says it's a function. If I go say hurrah and call it, it says hurrah. So you can pass that function, say hurrah, into a simple decorator function. So we'll try that. Simple decorator bracket say hurrah. Now that isn't calling it, that would just tell you what it is, and you think a closure. Ooh, what's a closure? Now that is what MicroPython calls an inner function. So you think, yeah, not terribly useful. So if you call it, it actually calls it. So it's print, I'm about to call the function, then it calls the function, and then it prints, I've just called the function. But that's all a bit clunky. You can take that line and redefine it to say hurrah. So you can go say hurrah equals simple decorator say hurrah. Right. So now if you type say hurrah, it will do the equivalent of simple decorator say hurrah. So we'll try that. Say hurrah. Yep, that's saying it's a function, but they're calling it a closure. Say hurrah, call it. Great. That's working very, very well. But there is a simpler way of doing this, and as it is all about decorators, I will show you. I will press stop, and that means it will get rid of all the functions and everything, so we know we're starting off on the clean playing field. Right, so I will put in the decorator as before, and then instead of just defining say hurrah, you can do it like that. Right, that means you're decorating that function with simple decorator. So that is exactly the same as going simple decorator bracket say hurrah. So if we go say hurrah, as before, it's saying it's a function, but it's a closure function. And if we do it like that, then it's working perfectly. I'm about to call the function hurrah, I've just called the function. Now, just to prove that things work the same way in Python as MicroPython, I'll switch over to Python. There, I will put in the simple decorator again, like that. I will decorate say hurrah. I will go say hurrah, and instead of it saying closure, it goes function simple decorator dot locals wrapper blah blah blah, which is about as useless as closure, but you can fix that. So I will stop, so I'm having a nice clean thing, and I'm in from functools, I'm importing wraps. If you don't have functools installed, you can do tools, manage packages, etc. Right, and then I will re-put in this, but the only difference is I've got at wraps bracket func there, and that is the wraps from there. Now if you just imported functools, that wraps would be at functools dot wraps function, and I don't know what it does, but it helps. So we go, we'll input this, the decorated function again, then we'll just go say hurrah, and it says is pass the name of say hurrah into the wrapper, so it is a bit more meaningful, which is good, and it still works if you, whoops, I'm pressing any key at random, then it still works. But can I do the same thing in MicroPython? So right, we're in MicroPython. I will import wraps, put in the decorated function, say hurrah. No, now that is a great disappointment to me. It doesn't work in MicroPython, so that is, I think it's that MicroPython is quite a honed down thing because it doesn't have room, so that is a big disappointment. So how do you pass in arguments? Right, we'll just get back to where we were. There's a simple decorator, and I've got somewhere right, another function which is say hello. So that is passing in an argument of name. So we go say hello. James. And it says say hello James. But what if we want to decorate it? Like that. And then we go say hello Arnold, and it doesn't work, it doesn't like it at all. Now that is because there you have a parameter, an argument, and there it says you didn't want any arguments. So this is all very annoying. You think, what can we do about that? So we will clean everything up, and here we have another version of simple decorator, and all I've done here is, instead of the wrapper having no arguments passed in, it's passing in star args and star kwargs. Now what that means, you can call the args and the kwargs anything, so it could be star cats, star dogs. It's star and the star that are important. The star means that you can pass in any number of arguments like name, address, whatever, and that will store them in a list. And you needn't pass in any at all if you don't want. And then the star kwargs is keyword arguments. So that means you could be passing in n equals 15, or address equals France. And that creates a dictionary called kwargs, or dogs, whatever you called it, with key pairs. So it would say name, colon, whatever, whoever your name is, can't think what your name is. And then it does the same thing again, calls the function again with args and kwargs, and prints the function. So we'll try running this one. No, we don't. We need to decorate, let's say hello, and try running it. Say hello. Arnold. And it works. And again, it says, I'm just about to call the function. It calls the function, which prints hello, and then I've just called the function. So that works wonderfully. But what if instead of printing it, you returned it? We'll do that. Say hello. I'm running out of names. Me. Well, it didn't go wrong. It did not go wrong, but that return, because I'm returning the function, it just doesn't do anything with it at all. So what you have to do is put that into a variable and then return it later. You don't actually have to understand this, because you'll just end up with a skeleton for your simple decorator, and then you can, it's good to know what is going on in it, but you don't have to worry about it. So this time we'll try again. We have the wraps, we have the args and the kwargs, we've got print, and instead of just going func blah blah blah, we're going return value equals func, and then it goes return value. So we will see what happens with the return. There. It isn't printing it, it's just putting it in the variable and then it's returning it. And you have to have the return after the print, because return is the last, it doesn't do anything, if you know what I mean. Once you've returned, you're gone. So we will say hello, Frank. There, it's worked. It's actually done it. So it's taken in the args and the kwargs, whatever you want. It says I'm about to call the function, then it puts it in there, it prints that, and it does the return the value, which is why they're in a different order, because you aren't doing anything there, you're just returning it, if you get my drift. But that is brilliant, that works. But all we need to do now is what happens if you don't have any arguments at all. Will it still work? Right. Yes, it works. Now, I count that as a success. Now, I've just made a file that has really all you need to know to make a decorator. So I've put from functools, blah blah, import time, because some of them want a time, and then you can just use that template for a decorator. And I've saved mine to the lib file of the Pico, and I've called it my decorators.py, and I've also saved it in my working directory when I'm using Python 3.10, or you can move it to wherever it would find it in the path, and all you have to do is save it like that, and when you create another decorator you can just add it afterwards, and then in your program you just go from my decorators import blah blah, and that will take in the from functools and the import time. Or if you don't want to do that, you could just go from my decorators import time this or debug or whatever you want to call it. But in that case you would need to put at least the from functools import wrap above it. So that's about all you need to do. Now I'll just stop this and I'll show you some of my example whatnots, decorators. Now this first decorator is just to slow down the program, so I've just used it for a countdown. This def countdown isn't very good, because if you count down from too much it will recur, and go round and round and round and round and round too much, and it will blow up. But it isn't that I'm testing, it's that. So we'll run it. There. Now I've just got two decorators, one which changes everything to uppercase and one which changes everything to lowercase. So we'll try running this. Yep. Hello, Dennis Ford, all in uppercase. Right, we'll try it decorating in lowercase, or lowercase, and it doesn't affect the exclamation mark or the 1, 2, 3. Now I've also got another one that is called swap case. Copy, get rid of those two, paste. Now the problem with this one is in Python 10 swap case exists in under string, and in MicroPython it doesn't. So what I had to do is I tried doing it, and if it says it doesn't exist I do it manually. So I will just demonstrate this one. Swap case. Yep. I could try putting a capital E there, and you can do all sorts of things. Capital O, and I can change that just to see what it's doing, and it ought to swap the case. Yeah, so that's Python 3.10 and that's my bit, but they both work the same. Right, this is just a timer function. Keith ought to like this. So again, there's a difference between MicroPython and Python 3.10. MicroPython doesn't have the dunder name in a built-in function, so I've put that in there. So it will find the name of it in 3.10, but in MicroPython it won't. And so I'm just wasting some time. And there we go, finished waste some time in 0 seconds. That was a bit fast. Let's try wasting a bit more time. 6. Oh yeah, that wasted a second. Then I could actually do it like that. So I'm just sleeping for sleep time, so that ought to be about 4 seconds. Yeah, 4 seconds. And the reason why I'm using end time, why I'm using time.time as opposed to anything else is that time.time is in MicroPython and Python 3.10. I think perf time or something is more exact in 3.10, but it doesn't exist in MicroPython. In MicroPython it might be time underscore ms or something, I don't know, but that's that one. You can also debug a function, and here's the debug decorator, and I'm using a built-in function which you can actually put a decorator on, and this is in Python 10.3, and there we go. It kind of does all the calling and returning and calling and whatever like that, and then it gives it, that's strange, let's say 5 terms. Yeah, that is 5 terms, and that's an approximate evaluation of E. Now if I switch to Pico and MicroPython, it will give a slightly different result. It gives the same numbers, but it's nameless, and that's because built-in functions of in MicroPython don't tend to have the dunder name, but it still gives the right results. So this decorator is a class, and it's counting how many times a function has been called, and so I'm decorating say hello with count tools, and then I'm calling it 5 times, and then I'm decorating say hurrah with count calls and calling it, and then I'm going back to say hello, and we'll just see what happens. So it's called 1, 2, 3, 4, 5 times on say hello, then it's saying hurrah, and then the call is independent of the call for say hello, and then when I go back to say hello, it is carrying on with so it's 6. So that's quite interesting.